Next problem. Three particles, each of mass m, are placed at the vertices of an equilateral triangle of side r, as shown in figure. The magnitude of the gravitational force on any one of the particle due to the other is root 3g m squared divided by 2r squared, root 3g m squared divided by r squared, gm squared divided by r squared, gm squared divided by 2r squared. Whenever the objects are rotating in a circular orbit more than 2, say 3, it forms a triangle. Usually, when 4 masses are rotating in a circular orbit, it forms, say, either rectangle or square. The question is, find out the magnitude of the gravitational force on any one of the particle due to the other two. Magnitude of the gravitational force on any one of the particle due to the other two. You have to calculate the gravitational force by taking the reference. Three particles of mass m are placed at the vertices of equilateral triangle of side r as shown in figure. The magnitude of the gravitational force on any end of the particle due to the other. Consider this mass, let it be A, this one B, this one C. Let us take the reference mass placed at C. This mass, the force TA, the force CB. It is a equilateral triangle. The included angle is 60 degrees. From the C, the A will be attracted. From C, B will be attracted. Therefore, the total force acting on C is FCA and FCB. Two forces are acting at a point C. We have to calculate the resultant about the point C. I think you have studied in the previous chapter, say in the first chapter, motion in plane and motion in straight line, the law of parallelogram of forces. The resultant of two forces using law of parallelogram of forces. Can you tell the formula? The resultant force using the law of parallelogram of forces. Anybody from the class? Huh? Tell me the law of parallelogram of forces. Anybody from the class? Now we were studying gravitational. Previously, have completed 5 and 6 chapters Nobody knows. Huh? You must know. Don't refer the book. Huh? How can you pass in the NEET examination without knowing the elementary information? Huh? All of you listen. See the board. You must be thorough in all the fundamental facts. Then only you can succeed in the NEET examination. Without knowing anything, without referring anything, studying anything, simply attend the class is not sufficient to clear the NEET examination. Daily you have to study at least 3 or 4 hours minimum for each subject. Huh? When two forces are meeting at a point B in equilibrium, and they are represented in magnitude and direction by the two adjacent sides of the parallelogram, then the resultant will be represented in magnitude and direction by the diagonal of the parallelogram. That is the law of parallelogram. To find out the resultant force, the formula is root of, say, a squared plus b squared plus 2ab cos theta. Cos theta. This is the formula to find out the magnitude of the resultant force. Angle made by the resultant force with respect to any one of the force, tan inverse of a divided by p plus q, a sin theta divided by a plus b cos theta. We must know this phenomenal concept, then only you can calculate the resultant force. Okay, right. Here, the two forces are acting at point C. We have to calculate the resultant of FCA and FCB about C. The resultant force is equal to root of FCA squared, FCB squared, 2CA CB cos theta. This is the formula to find out the resultant. Okay. First, let us calculate the individual force. According to the law of gravitation, G, mass placed at C is small m. With respect to A, another small m, divided by distance here r, therefore it becomes r square. Similarly, the force, the attraction force about the point C with respect to B is G m divided by r square. Both are equal. It becomes G m square divided by r square. Here also G m square divided by r square. Okay, now let us simplify this. Both are equal, no? Both are equal. Let us take it as F. Therefore, in this formula, R is equal to root of, say, F squared 2 F cos theta here 60. What is the value of cos 60? 1 by 2. Therefore, the 2 get cancelled. Finally, it becomes what? F squared. That is 3F squared. Takes root. It becomes root 3F. Now, the resultant is equal to root 3F. Now, substitute the value of F. This is the F. Can substitute either one of that value. This is the final formula. That is a gravitational force acting on the C due to the masses placed at A and B. That's all. Understand, students? Okay.
Yes, sir.
Okay. This is also a important problem. See this one. The gravitational force of attraction between the uniform sphere of mass m and a uniform rod of length L and the mass m as shown in figure. The gravitational force of attraction between the uniform sphere of mass m, and a uniform rod of length L and the mass m as shown in figure. How to solve this problem? Usually, to calculate the gravitational force between the two revolving objects or any body, you will measure the distance between the 2 points with respect to the centroid. With respect to the centroid. Here, the question is find out the gravitational force of attraction between the uniform sphere of mass m and the uniform rod. It is not a circular or spherical body. It is a rod. You have to locate the centroid. You have to locate the centroid. In this particular situation, when you do not know about the centroid of the rod or any object, we have to apply the integration method. Now I am going to apply the integration method between the capital mass and small mass. This is the body in which the mass is distributed uniformly. Here, I am taking a small portion of this rod. The length is dx. The position of this small portion of mass is at a distance x from the center or centroid of the mass capital M. Okay. Now, we are going to take two references. One is capital M and a small mass located at the distance x for the thickness dx. We have to calculate the mass of the small portion. How to calculate the mass of the small portion? For L length, mass is small m. For dx length, what would be the corresponding mass? So, இதனுடைய mass எப்படி calculate பண்றது? Small m for L length. அப்போ இவ்வளவு lengthக்கு அதனுடைய mass என்னவா இருக்கும்? That's all. Now, let us apply the gravitational force between the capital M and the elementary mass. Formula G mass capital M, small elementary mass small m divided by L dx. Capital M, M1, M2 divided by R square. What is the position of the elementary mass from the centroid of the sphere? What is that? X. X go. Therefore, as per formula, it becomes x squared. This is the governing formula between the mass and the elementary mass in the rod. When you integrate this formula, the equation, you will get the total gravitational force between the sphere and the uniform rod. What is the limit for this portion? This rod starts at the distance R, and yet at the distance L plus R from this point. இங்க இருந்து இந்த பாயிண்ட் எவ்வளவு டிஸ்டன்ஸ் இருக்கு? R distance. இன்னொரு upper limit என்ன? L plus R. That is the upper limit and the lower limit. Now apply the upper limit R plus L. Lower limit R. Now integrate this value. df becomes f. Capital G, capital M. All of you listen here. And then small m, L. These are the constant. The function is x. X is the function. Therefore, small r, capital L, small r, 1 by x squared dx. Okay. Next one. Before integrating, let us simplify again. It is integrated. What is the integration formula? Integral A. N plus 1 divided by n plus 1. Therefore, it becomes minus 2 plus 1 divided by minus 2 plus 1. Here, the denominator minus 2 plus 1 becomes minus 1. Therefore, let us take minus G capital M small m L. The remaining part is, what is that? Minus 1. Here, let us apply the upper limit and the lower limit. No. Upper limit is R plus L minus 1. Lower limit R power minus 1. Now, Okay. It can be written as like this. Again, take the minus inside. Minus R get cancelled. Therefore, final formula, final expression is becomes understand?
Yes, sir. Please scroll down.
Is it okay now?
No, sir. Sir, கொஞ்சம் scroll பண்ணுங்க sir.
Okay.
Okay, sir. Sir, இன்னும் கொஞ்சம் scroll பண்ணுங்க sir.
Downward, upward.
Downward, sir.
Down, sir.
Sir, please, accept your offer.
Two point masses A and B having masses in the ratio 4:3 are separated by the distance of 1 meter. When another point mass C of mass M is placed between A and B, the force between A and C is 1/3 of the force between B and C. Then the distance of C from A is how to find out this answer? 2 point masses A and B having the masses in the ratio 4:3. Two point masses the ratio of the mass A and B is 4:3, say 4/3. They are separated by the distance 1 meter. When another mass C of mass M is placed between A and B, the force between A and C is 1/3 of the force between B and C. Consider this is the mass MA. Consider another mass MB. The mass when another point mass of C placed between A and B, assuming that the another point mass is at a distance, a particular distance. The condition is the force between A and C is equal to 1/3 of the force between B and C. Then the distance of C from A, you have to find out the distance R. Both masses are separated as 1 meter. Put the distance in 1 minus R. ரெண்டு மாஸ் இருக்கு A and B, இதுக்கு இடையில ஒரு மாஸ் வச்சிருக்காங்க C. அதனுடைய மாஸ் வந்து capital M. The force between A and C is 1/3 of the force between B and C. It will be attractive force. This force is 1/3 of this force. There are two conditions given. One is the ratio of mass MA divided by MB is equal to 1/3, and another relation FAC is equal to 1/3 of FC, 1/3 of A, 1/3 of FBC. Okay, how to calculate the position of the mass M from the reference A? Now let us find out the first value FAC, the force between A and C. G MA M divided by R squared. F BC G F B M divided by 1 minus R whole square. Okay. Now use this values in this condition. G capital M R squared is equal to 1/3 of let us cancel this value. What about this MA divided by MB? MA divided by MB is equal to என்ன இருக்கு 1/3 ஏற்கனவே கொடுத்திருக்காங்க 4/3 கொடுத்திருக்காங்களா இல்ல ஈக்குவேஷன் முதல்ல கன்வெர்ட் பண்ணுவோம் MA MB is equal to 1/3 R squared divided by 1 minus R whole square. Already we have the condition as MA divided by MB is 4/3. This is 1/3 R square divided by 1 minus R whole square. As a result, the 2 cancel item. So cross multiply பண்ணுங்க 1 minus R whole square. இதை cross multiply பண்ணுங்க 3R whole square. Okay. So both sides square பண்ணீங்கன்னா left hand side என்ன ஆகும்னா 2 1 minus R squared cancel ஆயிடும். இந்த சைடு √3 வரும். இது R மட்டும்தான். ஓகேவா? இப்போ ஆன்சர்ல என்ன இருக்கு 2/3 இருக்கா? கேன்சல் ஆக மாட்டேதா? Yes. Kenapa? I'm not able to follow you.
Cross multiply அப்புறம் explain பண்ணுங்க sir. Sir, cross multiply அப்புறம் explain பண்ணுங்க sir.
Problem ah?
Sir, cross multiply அடுத்து explain பண்ணுங்க sir.
Okay, okay. Mistake okay. Just a minute. See, let us students listen here. FAAC. Just a minute. Just a minute, please. Students, kindly wait. Somebody is calling me. So substitute the values. See, listen here. G get cancelled. MA divided by MB. Then M get cancelled. Okay. Then R squared divided by 3, 1 minus R whole square. The next step is 4 by 3. That is equal to R squared 3, 1 minus R whole square. 3 get cancelled, becomes 4 r squared, 1 minus r whole square. Now take the root, it becomes 2. Take both side root. Okay. Then 2 minus 2r is equal to r. 2 is equal to r plus 2r. That is 3r 2. Therefore, r is equal to 2 by 3. Okay. Understand, students?
Yes, sir. Yes, sir. Hold on. Yes, sir.
Finish that?
Yeah.
Okay. Now, let us discuss about the laws of Kepler's law of planetary motion. Kepler's first law. The first law is, all of you listen, Kepler's first law. This is the law of orbit. This law states that every planet revolves around the sun when the sun is placed any one of the four. That is the first law. Take down this. All the planets move in an elliptical orbit with the sun situated foggy of ellipse means this is the ellipse, this is the major axis, the minor axis. There are 2 points equal distance from the center origin. This point is called foggy. The sun will be placed at any one of the four. The planets are rotating in a elliptical orbit. This is the first law. Second law, law of area. The radius vector covered by the planet in a given time will be equal, or aerial velocity is constant. That is called law of area. The radius vector drawn from the sun to the planet sweep out equal area in an equal interval of time. For example, consider this ellipse. The planet speed will be maximum when the planet is close to the sun. Our planet is in the shortest distance. The planet speed will be minimum when the planet is at the farthest distance. Consider a planet, all of you listen. Consider a planet is moving from this point to this point. This is the position of the sun. From this point to this point. This is the area swept out when the planet moves from, say, A to B. It will be equal to the area swept out when the same planet is moving from C to D in the same time. That means the time taken by the planet to move A to B will be equal to from B to D, provided the time is constant. According to the second law, this area will be equal to this area, provided the time required for the planet to move A to B is equal to the time required to move the planet from C to D. Same time la area எவ்வளவு ஸ்ப்ரெட் பண்ணுதோ அந்த ஏரியா ஈக்குவல் அப்படின்னு சொல்றாங்க. It is a radius vector drawn from the sun to the planet, sweep out equal area in an equal interval of time. It also explained that the area is covered with respect to time is constant. This is the mathematical statement of this law. It's called areal velocity. Area with respect to time, areal velocity. Okay. Angular momentum. The area covered in t second. And the planet is moving in the elliptical orbit of r squared d theta. Therefore, the areal velocity with that, we finish today. We will continue in the next class. The remaining chapter, escape velocity, variation of gravitational force above the earth, below the earth. We will discuss in detail in the next class. Have you copied?
Yes, sir. No, sir.
No. No or yes?
No, sir. Please, sir.
Okay. We'll see in the next class. Kindly revise all the concept did in the previous class when you come to the next class. Okay.